On this video, we're going to break down the OSI model. Welcome to StudioSec. Thank you for watching. Be sure to like this video if it's helpful. Comment down below if you have any comments on the OSI model, and subscribe for more content I'll be posting every week. If you're new to IT, you've probably heard the OSI model before. It's the cornerstone of any IT career. Knowing what level events happen will help you to troubleshoot these different processes. OSI stands for Open Systems Interconnection. The OSI model provides a 7-layer graphical display on how data is moved and presented. These 7 layers are application, presentation, session, transport, network, data link, and physical. Here's a fun phrase for you to practice. All programmers seem to need data processing. Let's say that again. All programmers seem to need data processing. That'll give you a top-down phrase to remember: application, presentation, session, transport, network, data link, and physical. Now let's break these down. We're going to do this in reverse order. In other words, we're going to do this from the order of you watching this video. We're going to start with layer 7, application. The application layer provides network services to end user application. For instance, whenever you're watching this YouTube video, that's on application 7. It is unpacking the content and presenting it to you. Layer 6, presentation. The presentation layer converts the traffic for use in application or vice versa to be transported across a network. Whenever you're watching this video using HTTPS, since that S is secure, that's encrypted. So on the presentation layer, this video is being decrypted and then passed off to layer 7, application. Inversely, if you want to shoot me a negative comment or a positive one if you're a friend, it will encrypt that message and send it down the stack. Layer 5, session. Session manages the flow of traffic. For instance, your device is running several different processes, some in the background and some in the foreground. So session is managing the flow of data so that way it ends in the right spot. Layer 4, transport, moves data between network devices. Common examples of this are TCP and UDP. And TCP is a two-way connection and UDP is a one-way connection. And to kind of break that down a little bit more, think of TCP as like you and I have a handshake. In fact, there is a TCP handshake. And that's where both of us are engaging in communication and we're exchanging feedback, be it through the handshake, that allows us to know that we're connected. However, with UDP, that's if I were just to shout at you and I'm not checking to see if you're listening or not. I'm just screaming at you. So right now, while you're watching this video, your device is communicating with YouTube servers to be able to get packets to watch this video. Layer 3, network. The network layer provides mapping for moving data from point to point, and it does so using an IP address framework. You should be familiar with what an IP address is, but if you're not, it's a unique identifier for your device on any particular network. So if you're on your home network, you may have a private IP address, and there are certain private IP address ranges that are specifically reserved to be private. Your device has a unique private IP address, and those connect to your router, and your router has a public IP address. Now your router will use that public IP address as the source when it's sending requests out to the internet, say to Google, and the Google IP address will be the destination address. Layer 2, data link. Data link digests this information from bits to frames. Many frames make up what you are viewing right now. Now what does that conversion from bits to frames mean? Well, it's because those bits are actually being transported on the physical layer. Layer 1, physical, will make up your physical devices like Ethernet, fiber optic, and other kinds of transmission items. And these convert those bits into some kind of a physical transmission medium, from lights to different kinds of radio waves to whatever it is that that medium supports. So this is a very complex topic and requires a lot of research to fully understand. I've attached in the description a document that I thought was very helpful for me. It was written by Bradley Mitchell from LifeWire, and it really succinctly breaks down all these different pieces, and it should help kind of visualize what exactly is going on here in the OSI stack. Be sure to like if this video is helpful. Comment down below if you have a favorite OSI layer and you want to tell me about it. And subscribe for more content. I'm posting more content every week. Thank you.
Et tu préfères la donner.